Welcome to another YouTube tutorial on one of the fundamental concepts in circuit analysis, linearity and superposition. Whether you are a student learning about electrical circuits or an electronics enthusiast looking to deepen your understanding, this tutorial will guide you through the principles of linearity and how the superposition method can be used to simplify complex circuits. By the end of this video, you have a clear grasp of the concepts and be able to apply them to solve various circuit problems. All of the circuits which we plan to analyze can be classified as linear circuits. So this is a good time to be more specific in defining exactly what we mean by that. Having done this, we can then consider the most important consequence of linearity, which is the principle of superposition. This principle is very basic and it will appear repeatedly in our study of linear circuit analysis. As a matter of fact, the non-applicability of superposition to non-linear circuits is the very reason they are difficult to analyze. The principle of superposition states that the response in a linear circuit having more than one independent source can be obtained by adding the responses caused by the separate independent sources acting alone. Let me say that again. The principle of superposition states that the response, whether it's current or voltage, in a linear circuit having more than one independent source. The response in a linear circuit having more than one independent source, that is a circuit that is having more than one independent source. In the last tutorial, I talked about dependent and independent source, how you can recognize a dependent source and independent source. So here in the principle of superposition, we only apply this principle to circuits having a number of independent sources. So the response, which can be current or voltage in a linear circuit having more than one independent source, can be obtained by adding the responses caused by separate independent sources acting alone. I will explain what that means in the meantime. So what do we call a linear element? How do we recognize a linear element? So linear, in mathematics, we say that a linear curve is a curve that obeys the rule of y is equals to mx, right? That is, the degree of the equation of that line is 1. So we define a linear element as a passive element that has a linear voltage to current relationship. That is, the relationship between voltage and current is linear. Ohm's law, basically it should obey Ohm's law. So the relationship between voltage and current here is linear. Is it not? Are they not the same? They are identical, right? V represents y, I represents x, and r, which is the gradient of the voltage current curve. That is, if you draw voltage and current on a curve, right, the gradient of that curve is the resistance. So that's a linear element, an element that has a linear voltage to current relationship. So by linear voltage current relationship, I simply mean that the multiplication of the current through the element by a constant results in the multiplication of the voltage across the elements by the same constant, right? So if I multiply the current, for example, now if I multiply the current by 2, the voltage will also be multiplied by 2, right? Because this will now be 2i, right, multiplied by r. So the second v now will now be what? 2ir, and which same thing as 2v, which means I have multiplied v by 2 also. Do you understand? So it means that the multiplication of the current through the elements by constant results in the multiplication of the voltage across the element by the same constant. At this time, only one passive element can be defined, and which is a resistor. An inductor, a capacitor, they are passive elements, but they don't have linear relationship. That is, the voltage and current in those elements do not have linear relationship. So at this time, at this your level of circuit analysis, you understand that we'll be dealing with resistors as the only passive element that has a linear relationship in between voltage and current. So basically, let's go into the superposition principle and see what we can do and see how it is applied to circuits. Remember, I was saying that the principle is only applied to a linear circuit with more than one independent source. So, and what is done when we have more than one independent source? We can break the circuit into independent circuits having just one source. So we will now get the response of each source and add them together to get the total response of the circuit. We'll see how that is done very soon. This is the circuit we will use to explain how to apply the superposition principle to solve for variable of interest in a circuit. So, like the superposition principle said, it states that the response in a linear circuit having more than one independent source can be obtained. Look at it. How many independent sources do we have here? We have two independent sources, the voltage source here and the current source here. It can be obtained by adding the responses caused by the separate independent sources acting alone. So which means that we have to separate these independent sources, right? So we have to separate this, we have to separate this. So if I draw two circuits to show that, right, so which means that if we are removing the current source, let me write it down. If you are removing the current source, you open it, right? When you remove the current source, you are opening because current is not flowing again, so it has to be an open circuit. So we open circuit current source. And the second one is for the voltage source, you short circuit. Short circuit means that when you remove this voltage source, that is, there's no voltage drop on it again. That doesn't mean that current is not flowing, right? So short circuit means that you just continue the line. You remove the source, you just continue the line. But the current source, when you remove it, you open circuit, which means that you are not joining the lines together, right? So this is a short circuit. So let's draw the circuit now. So the current here, we'll say it is Ix prime, because it's not the full Ix. We've removed the source, so it cannot be this Ix again, right? So 9 ohms and 6 ohms, then plus minus 3 volts. So right now this voltage source is acting alone, just like the principle of superposition says. So this is the first circuit. The second circuit is when we now short circuit the voltage source, right? We want to make the current source stand alone, therefore you have to short circuit the voltage source. So right now these are our two circuits, then this is 2 amperes. So we have to solve each of these circuits one by one to get Ix prime and get Ix prime prime, right? So this is an open circuit, you know that current is not flowing through, so therefore 6 and 9 ohms, they are in series. That is, when two components are in series, same current flow through them, right? So when the current is coming here, nothing goes here, I here is equals to 0, right? All the current that is coming here goes through the 9 ohms, therefore 6 and 9, they are in series. And remember what I said when we did current and voltage division. If you don't know anything about current and voltage division, I will advise you to go to our video on nodal analysis. That's where I explained what voltage and current division means. So here we have two resistors in series, and therefore we are going to do what? Voltage division. Like I said, if you don't understand what I'm saying, go to our video on node analysis, I explained what voltage and current division means. So let's go. So we are going to do voltage division here, right, so that we can know the voltage on 9 ohms. The current we want to get is the current flowing through 9, right? Or if we can get Ix straight, because since same current is going through 6 and 9. So that's one thing about circuit analysis. You can get your answer in different ways. From here, I can decide, I can use like 4 or 5 methods to get the answer for Ix prime, right? So, but the simplest one is to do what? Just use Ohm's law, right? So since the same current is going through 6 and 9, so I will say that Ix prime is equals to what? Ohm's law, which is V over R, 3 volts over, they are in series, 6 plus 9, which is 3 over 15, which is what? 0.2 amperes. Right, this is just using Ohm's law. So if I want to use voltage division method, right, so I have to get the voltage on 9. So the voltage on 9, let me call it Vx prime, is what? 9 over 9 plus 6 multiplied by 3, which is what? 9 over 15 multiplied by 3, and therefore will give us 27 over 15, which is same thing as 9 over 5, which is same thing as 1.8 volts. And therefore Ix, using Ohm's law, we are still coming back to Ohm's law, is what? 1.8 volts over, what's the R? 9. And therefore will give us 0.2 amperes. You can see that we got the same answer. So which means that when the voltage source is standing alone, Ix prime is equals to 0.2 amperes. So let's get this now. Ix prime. So this is very, very straightforward. You can see that 6 ohm and 9 ohms, they are in parallel, and we have a current source. From the video on node analysis where we did voltage and current division, it should be very, very glaring that we are going to do current division here. We're going to apply current division. So that is, we get the current going through 9, we are going to divide the 2 ampere current. So if you do that by current division, Ix prime by current division, Ix prime will be 6 over 9 plus 6 multiplied by 2, which was 6 over 15 times 2, that's 12 over 15, and of course that will be 0.8 amperes. That is very, very simple. And therefore Ix, the normal Ix we are looking for is Ix prime, that is when the voltage source is acting alone, plus Ix prime when the current source is acting alone. I remember that we got Ix prime to be 0.2 amperes. So an Ix prime is 0.8 amperes. So by principle of superposition, Ix will be equals to 0.2 plus 0.8. Ix will now be equals to 1 ampere. I believe that is very, very simple to understand. If you have any question on what I just did right now, please drop it in the comments and I will make sure I answer you. This is the second example that I will use to explain the superposition principle. So how many sources do we have in this circuit? We have 3. 2 independent sources and 1 dependent source. But don't forget, in our theory, in our principle of superposition, it states that we only take care of independent sources. That is, we only separate independent sources. So dependent sources doesn't concern us in this case. It doesn't concern us, that is, in a circuit that is having more than 1 independent sources. I didn't say dependent sources, right? That is having more than 1 independent source. So what do? We add the responses caused by the separate independent sources acting alone. So what do we do here? So we only separate independent. We have two independent source, which is the 10 volts voltage, the 10 volts voltage source, and the 3 ampere current source. So drawing our separate circuits for the independent sources, we short circuit voltage source, short circuit voltage source, and we open circuit the current source. So short circuit, if we want, let's make the voltage source to stand alone, and therefore we open circuit the current source. So what do we have? We have this. The dependent source is still alive. We are not removing it. And therefore we open this, right? This is 2 ohms. And we'll be naming our Ix as Ix prime here, right? It is not Ix again because we've already removed the source. So Ix prime, and from here you can see that this is a single loop circuit. This is a single loop circuit, and because it's a single loop circuit, I can apply KVL. I can apply KVL. If you don't understand how I got it that I want to apply KVL, you can go to our first tutorial on Kirchhoff's law. We applied KVL to get some certain variables of interest in that tutorial. So applying KVL to the circuit, so what do I have? I have this going, we are going clockwise. You can see the direction of Ix prime. So if I get to 2 ohms, I will have 2 Ix prime. When I get to 1 ohm resistor, I will have Ix prime, that is 1 times Ix prime. Then when I get here, it's entering the positive, so it will be plus 2 Ix prime. Remember, it's a voltage source, so I don't need to multiply it with Ix prime again. Then when it gets here, it is minus, it is entering through the negative because we are going clockwise. That's minus 10. That's all, and is equals to 0. So if I combine this, what will I have? I have 5 Ix prime is equals to 10, and therefore Ix prime is equals to 2 amperes. Right? That is very, very simple and straightforward. So let's now short circuit the 10 volt voltage source. So short circuiting that, we have this, the 2 ohm resistor, then the 1 ohm resistor. Remember, this is still there. Then we have the current source at the middle. And we'll name our Ix here as Ix prime prime. And of course, this is plus minus, and this will be 2 Ix prime prime. So look at this. What do we need to do here? We have 2 ohms on the other side, which is parallel to 3 ampere current source, of course, and parallel to the combination of the 1 ohm resistor and the 2 Ix voltage source. That is a current controlled voltage source. This is already explained in our tutorial on nodal analysis. So I can use a method here in which we are going to treat in the next lesson, which is called source transformation, so that I can simplify it to a single loop circuit, just like what I have here. So using source transformation, I will simplify it with just one trick. It return to this single loop circuit, and therefore I can apply KVL. But since we don't do that yet, and I don't want to go into it yet, in where we will talk about this in our next tutorial. So we are going to apply KCL. We are going to apply Kirchhoff's current law, and this will help us to solve and get the answer for this problem. So we want to get Ix prime prime. So of course we have more than one node there. This is a node, right? This is a node, and this is another node. By nodal analysis, I'll make this what my reference node. I'll make this my reference node. So this is the reference node. Then KCL at this joint. Right? So let me name this V. By nodal analysis, what do? You designate nodal voltages to your non-reference nodes. So the voltage at this node is what? 2Ix prime prime. That is very, very easy to know, right? Because the potential difference here is 2Ix. So which means that the potential difference at the two terminals will be this minus this. This is already 0, right? That is 2Ix prime prime must be equals to the node voltage here. Let me call it V naught minus 0. So which means that V naught is 2Ix prime prime. That's why the node voltage here is 2Ix prime prime. So let's now apply KCL to this node. Applying KCL to this node, remember I said that we will assume all currents to be going out except it is otherwise stated. So which means that this is going in, right? Because it has already been stated. 3 ampere is going in. It has already been stated, but this is going out. So let us apply KVL to the node voltage V. So at this node voltage, this is entering, right? Ix prime prime is entering. This is going out. Like I always say, we always assume that it's going out unless otherwise stated. Then this is going in. So current going in is equals to current going out. So Ix prime prime is going in. So we have Ix prime prime plus 3 is equals to V minus 2Ix prime prime over 1. That will give us what? V is equals to 3Ix prime prime plus 3. That is very, very easy to get. These two currents are going in while this is going out, right? And therefore that gives us this equation here. So but what is V in terms of Ix aside that equation? So from here you can see that Ix prime prime is 2 ohms, is the current flowing through 2 ohms. But I can write it in terms of V. That is Ix prime prime is, right, it is coming from here, that is from the reference node, which is 0, to the node voltage V. So that's 0 minus V divided by 2. Ohm's law. Ohm's law is I is equals to V over R. So the voltage, the terminal voltage, the potential difference between the two terminals is what? 0 is coming from here, minus V divided by the resistance 2. That's minus V over 2. So Ix prime prime is equals to minus V over Ix prime prime is equals to minus V over 2. Which means that what? V is equals to minus 2Ix prime prime. So if I should substitute this in this equation here, so what will I have? I will have minus 2Ix prime prime is equals to 3Ix prime prime plus 3. And therefore what do we have? We have 5Ix prime prime to be equals to minus 3, and therefore Ix prime prime is equals to minus 0.6 amperes. So what does superposition say? Superposition says that Ix is equals to Ix prime plus Ix prime prime. And what do we get as Ix prime? We got Ix prime as 2 amperes, which is this. That is when we open the current source, that is when the voltage source is standing alone, and Ix prime prime is when the current source is standing alone, and we have 2 plus minus 0.6. Ix is therefore 1.4 amperes. I'm very sure we understand how this is gotten. Ix is equals to 1.4 amperes. So that is the current Ix flowing through the 2 ohm resistor. We apply the principle of superposition to get this variable. This will be the end of this tutorial, and if you have any question, you can drop it in the comments and I'll give you an answer. Thank you very much, and see you in the next tutorial.